This will be the second part of the 9th problem, which I started in the last video. In this video, we will complete the series parallel circuit problem. Once I am finished with this series of problems, I'll be posting them in my stand store at this web address. Following up from our previous video, our next step will be reversing the process to calculate the current in each branch, which then allows us to calculate the current in each resistor. Because R1 is in series with a previously calculated equivalent resistor, all of the current that flows to the load now flows through both of these resistors. And that equals 776 milliamps. So we have solved for the current flowing through one of these resistors, R1, which is 776 milliamps. In order to find the current through the other resistors, all we have to do is work backwards like this. Remember that the other resistor was made up of two parallel resistors. The total current emanating from the source will split between these two parallel paths, one of which is through the 100 ohm resistor and the other is through the 95.3 ohm resistor. Applying current division, the 100 ohm resistor will see 379 milliamps. The rest of the total current will flow through the 95.3 ohm resistor. Remember that these two parallel resistors were made up of two sets of series resistors that look like this. Because these two resistors are actually made up of two sets of resistors in series with each other, the current that we just calculated will flow through each branch and each pair of resistors, as you see here. So this provides us with three more answers. The current flowing through R2, R3, and R6. In order to find the current flowing through the remaining resistors, R4 and R5, we have to remember that they are in parallel and will look like this. The 397 milliamps will flow through the parallel combination, but split like this in proportions that are determined by the value of the parallel resistors. Applying current division, we can find the current through the 45 ohm resistor, which is 397 times 37 divided by the quantity 45 plus 37, which is equal to 179 milliamps. To find the current flowing through the 37 ohm resistor, we could apply the current division again, or simply just subtract 179 milliamps from the total current flowing through the parallel circuit, which is 397 minus 179 equaling 218 milliamps. This provides us with the current through the last two resistors, R4 and R5. And our work is now done. This video is part of my electrical technical information series. In this series, I'll be covering essential topics to help you understand electrical systems. These topics are small excerpts from my courses located in my stand store, which you can access by going to this web address. Before exiting this video, I want to make you aware of some huge sales that are coming up for members of 𝐃𝐈𝐒𝐂𝐋𝐀. 𝐃𝐈𝐒𝐂𝐃𝐈𝐒𝐂𝐋𝐀 is a company that specializes in portable power stations, solar generators, and battery storage systems. It offers eco-friendly and reliable power solutions for outdoor activities, emergencies, and off-grid living. Their products include high-capacity lithium batteries with multiple outlets such as USB, AC, and DC, and compatibility with solar panels, making them ideal for providing power in remote locations during power outages. Bluetti is popular among campers, RV owners, and those seeking sustainable energy solutions. Their power stations come in various sizes and capacities, catering to different energy needs. To find out more and take advantage of this sale, simply click on this web address.